Hello everyone. We are going to talk about today uh, exploring machine learning for .NET developers. In this talk, I'm going to cover some pretty basic concepts and of what machine learning ML.NET is, how to use machine learning, and will do quick demos in which are very helpful when you are trying to work on your harnessing your machine learning skills. So in this is all about me. I am Niloshima. I have close to 11 years of Microsoft Technologies experience in various product and a service-based organization, and currently I'm working as a lead SC3 at Digital Control Incorporation. I'm a cloud architect. I write blogs as and when get I time, and I have been a speaker since last couple of years now. You can reach me at niloshima@brewingcoach.com, and if you would wish to connect me, have a chat about anything, you can reach me at LinkedIn as well. So this is what we are going to cover today. So we will be talking about we'll be talking about an introduction to ML.NET, what Apache Spark offers for .NET Stack in supporting ML.NET framework. Then we'll talk about how to add intelligence with cognitive services landscape, and we'll see some concepts around Azure ML. So let's get started. So what is machine learning .NET? ML.NET is basically an open source and a cross-platform machine learning framework. So by open source, I mean that it is available to download on GitHub, and by cross-platform, I mean that it is supported on Windows, Linux, and Mac OS. It is built for .NET developers. So with ML.NET, you can use your existing .NET skills to easily integrate ML in your .NET apps without any prior machine learning experiences. ML.NET offers AutoML and productive tools to help you easily build, train, and deploy high-quality custom models. It allows you to leverage other popular libraries like Infer.NET, TensorFlow, or maybe ONNX for additional ML scenarios. And you can use the same ML framework which is used by recognized Microsoft products like Power BI, Microsoft Defender, Outlook, and Bing. So it is trusted, and it gives you a whole new new form of scalability because it's proven at scale. Okay, so like I've mentioned, it lets you to reuse all the knowledge, skill, code, libraries you already have as a .NET developer, so that you can easily integrate machine learning in your web or maybe mobile application or desktop application, maybe games or IoT applications. Let's just try to talk more in terms of there are a couple of buzzwords which are there present in the this whole machine learning space. So there are a couple of hype-up terms. So to understand better and ML.NET, we just need to I'll just quickly try and explain a couple of hyped up terms, like what is the difference between artificial intelligence, machine learning, maybe deep learning, and artificial neural networks. So these are the buzzwords which people often use together, and this could be confusing. So when it comes to understanding the basic and difference between how things work, so I'll try to explain these terms in a very simplified way to the best of my knowledge. So what is artificial intelligence? So there are many definitions of AI, and here's the one which I think is very good. So AI involves machine that can perform tasks that are characteristics of human intelligence, and this is basically given by John McCarthy. So the statement is general but implies a lot of things. It means AI is all about mimicking human intelligence, which is about remembering, learning, understanding, and recognizing things in the world, which are very complex things to do. So AI is much more than its definition, as there are many forms of AI and ways to implement it, of course. Then comes the machine learning. Machine learning is a term which we use a lot together with AI, and according to Arthur Samuel, machine learning is a field of computer science that gives the computer the ability to learn without being explicitly programmed. So ML is all about the ability to learn. You want computers and applications to be able to learn instead of you programming many possibilities hard-coded. And ML is already used in a lot of application. It is used to detect patterns. It is used to do sentiment analysis, and we have been using those applications since long. There are two more terms which I would like to quickly touch. The first one is artificial neural networks and deep learning. So these are sometimes confused for ML, and something that can help with that. That is not completely wrong. How it all fits together is an explanation could be machine learning can be done using different techniques, and all of these techniques machine learning algorithm uses to find patterns in the data. You can do ML using artificial neural networks, which uses the algorithm that mimics the way the human brain works. Deep learning is also a machine learning technique, and it learns through many layers of analysis, where each layer works with the input from the previous layer. So some deep learning architecture uses artificial neural network, and there are many more machine learning techniques like Bayesian network or clustering. So you can use all of this to discover patterns in data. So machine learning itself is a way to implement artificial intelligence. So it is an overall concept in which machine learning lives. So now we know, at least understand the basics of these concept. I would like to explain a little bit more about how machine learning work. So we use machine learning to analyze the data. This data contains patterns like with your smartwatches, we have a heart regulator pattern. So we see whether the heart rates are regular or not. So this data contains pattern like which heart rates are regular and which ones are irregular, and might indicate an anomaly. So we analyze this data using an ML algorithm like deep learning or clustering. Then these algorithms are basically useful in finding the patterns in the data, and with those it creates a machine learning model. So this model is the thing that can recognize patterns, and creating this model is also called training the model. Now the application will consume this model via input their data and see if it matches to the pattern. That is machine learning. So one of the most difficult portion of this job is to prepare the representative data, which talks about the problem at hand, that has enough volume and diversity, and also contains the edge cases. So you need to know the data that you are working with and how to manipulate that data. And the next thing is the process to create and test your machine learning algorithm, and that can be created in with many different techniques like deep learning or maybe consuming an artificial neural network. So when you have created that data, created and tested the algorithm, you then need to expose the model to the application that are going to consume and use your ML algorithm. And there are a lot of tools that can do that for you. right? But this is not a trivial task, I would say, and you need to make sure that whatever you have exposed is available, performant, and secure. Having said that, we always get confused and you know, or I would rather say that we always have a couple of questions in our mind, that since Microsoft has a lot of AI ML offerings, we have Azure Cognitive Services, we have Azure Machine Learning, and then now this ML.NET comes into the picture. So what is the difference between them? So Azure Cognitive Services is basically a cloud service that provides pre-built AI and machine learning models to add to your application, which includes basically a set of APIs to use a variety of models for natural communication methods with vision, speech, text, something like that. Azure Machine Learning is comprehensive environment in the cloud, you know, where you can host your end-to-end machine learning model life cycle, including model training, versioning, deployment, and release management at cloud scale. Whereas an ML.NET gives you the flexibility of building custom machine learning solution and integrate them in your .NET application. So it is supported on both .NET Core versions and .NET Framework as well. You can it is 100% free since it is open source, and you can use it with C# and F#. So, and it is very easy to install. You just need to install add basically ML.NET by as simple as adding Nugget package, or you can basically install a Visual Studio installer, extension installer, ML.NET model builder, and if you are a CLI fan, you can pretty much go ahead and install ML.NET CLI for Windows, for Mac OS, and for Linux, depending upon what operating system you are using. So having said that, let's just see what and all offerings ML.NET basically gives to us. So these are a couple of offerings which I have just listed, which we, I mean, as in technology people, we know, and we have somehow, you know, used it in terms of you know, in one application or the other. So we have sentiment analysis, where you can analyze the sentiment of the customer reviews using a binary classification algorithm. We have price prediction, which is basically used to predict fares based on the parameters such as, you know, how much the distance you are traveling, if you have ever used a Uber. And in the background, it uses a regression algorithm. We also have fraud detection, object detection. So fraud detection is basically to detect fraudulent transaction, and it also uses binary classification algorithm in the backend. Object detection is basically used to recognize the objects in an image, which uses basically an ONNX deep learning model. Then comes image classification, which is used to classify images using a TensorFlow deep learning model. And we have product recommendation, we have customer segmentation. So product recommendation is basically, we have used or we might have seen product recommendation in a lot of e-commerce website. We have used say Amazon.com or Amazon.in. It gives you a lot of you know, it recommends you a lot of product based on the purchase history, and in the backend it uses matrix factorization algorithm, and it gives you a lot of these are just couple of features which I have listed, but it gives you a lot of you know, many offerings in terms of you know, where you would like to just go through. You have a huge sample available on GitHub. So you have sales spike detection, you have customer segmentation, you have sales forecasting, so on and so forth. So let's just move to and how do you achieve that? You achieve that by creating a model which is capable of, which makes which make it super easy to build your customized model. And to do that, Microsoft offers Model Builder. It is a UI based tool and ML.NET CLI to make it super easy to build custom ML models. So I'm gonna I'll just give you a quick demo when it comes to leveraging the ML.NET Model Builder. So here I have my my basic console application, and I'm simply opening it. This application is in .NET Core, you can see, and this is you just need to go ahead and like I have mentioned, you just need to go ahead and install the installer in your application. So I've simply created a new project, and I have marked it as a C# console application. And now, since I've already installed the extension, I am simply going to add machine learning to the project, and it is as easy as that. So to generate your model, you need to select your machine learning scenario. So I am quickly going to select text classification, and then basically you need to select the environment. So I would like to run it in my local CPU environment, and then all I need to do is basically to add the data. So I have already downloaded this data, this Wikipedia detox 250 line data.tsv, and it is already in my application directory. And you can simply go ahead and add the data, which is a file based data or an SQL server based. These two are supported as of now, so I have selected file. Just need to go ahead and browse the file, and once this file is browsed, it will give you the preview. And then you need to select a label under column to predict. So I am going to select sentiment here, because this is the label is this label is what I am predicting, and which is the first column of the data set. And then you would like to select the input columns, which are used to help predict the label. These are called features. So the review comment is the feature, something like that, if we are probably reviewing the sentiment. So I am going to do an uncheck logged in and select sentiment text. And the next thing which I am going to do is basically train the data. So what I'm going to do, I'm simply increasing I'm simply increasing the time, and if I do start training, it is going to train my model. So Model Builder evaluates many models that varying algorithm and settings to give you the best performing model. So for now, I have selected time to train as 90 seconds. This is the amount I'd like my Model Builder to explore various models. So if you have a longer data set, you should set a longer training time. And then when I clicked on start training, it start the training process. And once it is done, I would be able to see training results here. And in that result, I'll have best accuracy, which is basically, which allows which gives us the accuracy of the best model that Model Builder has found. Higher accuracy means means the model predicted more correctly on the test data. We get best model, which gives us the algorithm which performed the best during model builder's exploration. We have training time. This shows us the amount of the time that was spent training or exploring the model, and then we have models explored in total. So this gives us the count of the number of the models explored by model builder in the given amount of time. So here, you can see here, it looks like this is going to be done, and my training results should be visible any second now. So you can see that it took close to 90 seconds, and since I've increased the time, and this is the training result I was talking about. Another thing is to evaluate your evaluate your model. So you can make prediction on the sample input section here, and sample data, and you can try your model. So this is basically the first line of the data set, which is basically I can pretty much go ahead and change it. I also have that flexibility. So and if I go ahead and click on predict, you will be able to see the result. It says that it is 100% root, right? So 1 means a negative sentiment and 0 means a positive sentiment. So that's where it is. That's what it tells us. And if I go ahead and do next step, you would be able to consume this particular code which model builder had just created for you. So what it does, it model builder adds both machine learning model and the project for training and consuming the model to your solution. And if I go ahead and do add to solution, it'll I have already tried it before this activity, so that's why it gives me that you want to replace it. And you can see here, it gives you a lot of functionality in terms of this is your input class, what it has sentiment, text, and we have like 3 fields in the application. So this is how easy it is for you to add your to create your model and then to consume your model. So that's how I am going to basically I mean that's all about machine learning model builder. Now you can just go ahead and in your program.cs you can just simply give some input, and you can get a model output which is basically which gives you it is basically load the model and then predict the output of the sample data which we have just entered, right? You can do that by writing something in your main function, something like input, which is basically of model input type, and then you have to add the sentiment text there and you will get the output. So that's how you do it. Let me show you how to do that. So I did var input data is equals to new model input, and input data dot sentiment text is equals to, this is super root, and let's just try and fix it. Why it's not working? Okay, this is nothing fancy, and you would be able to write model output is equal to consume model dot predict, and you just pass your input here, which is input data, and it gives you the result, right? You can pretty much go ahead and write it in a console line that something like, just copy it and like do a output here. You can make it fancy if that is the requirement of your application, but that's how you basically go ahead and write it when it comes to, I mean, that's how you go ahead and consume the model when it comes to your machine learning algorithm. So let's just see why this is not working as of now. It is working, I just need to build it. Apparently it does not have the dependency, but you anyways know this is super easy for you. So that's how you can fix this problem by adding the references and see why it is not working. Maybe I can just go ahead and do that, which is like using system here, and you need to update the dependency here. If you would be able to update it, you would be good to go. Yeah. These are just various ways to consume your ML model with the help of AutoML, and then use it in your application. Having said that, let's just move towards the next topic. So it gives you the flexibility by it provides a good integration with TensorFlow. So it is a super exciting field, and the language of choice for machine learning is Python, and the most popular library is Google's TensorFlow. Almost all code examples are written in Python and depend on TensorFlow and NumPy libraries. So this can be a problem for us C# and .NET people. We are confronted with a stark choice: either learn Python or use .NET machine learning libraries and write our own code, C# code from scratch. So that's where it gives you the flexibility, where you can use it with TensorFlow, and you can integrate it and get get the get the output in less amount of time. So ML.NET has been designed as an extensible platform so that you can consume other popular frameworks, and you have access to even more machine learning scenarios like classification, object detection, and many more. And these are pretty easy when you are trying to leverage the existing framework. This repository gives you a lot many example which are basically on C#, and you can see it basically gives you a flexibility where you can, it is basically a sample code which you can leverage for object detection, and in the back end it uses TensorFlow algorithm, ONNX, Open Neural Network Exchange algorithm format. You can pre-train the data, you can use your own model, and this is how it works for you. So having said that, let's just move towards the next item in the agenda, which is .NET for Apache Stack. So what is Apache Stack? Apache Stack is basically a unified analytics engine for large-scale data processing. So Apache Stack achieves high performance for both batch and streaming data using a state-of-art DAG scheduler, a query optimizer, and a physical execution engine. So Apache Spark gives us the Apache's .NET for Apache Spark gives you APIs for using Apache Spark to form C# and F#. So within the .NET APIs, you can access all aspects of Apache Spark, including Spark SQL for working with structured data and Spark streaming, right? So and this is something which is it is written on top of Spark interop layer, designed to provide high performance binding. And this little semicircle gives you the idea of the performance. This is more or less a performance matrix of Apache Spark, and you can see here it has a very huge flexibility, and it has a very good set of performance implications associated to it. So what you need to do, you need to install .NET, or you need to install Java, you need to install some compression software, and then you need to install Apache Spark, and then go ahead and install .NET for Apache Spark. You have to install some Windows utilities if you are on a Windows machine, and then you just need to set the environment variable, and you would be good to go. Once you are done with that, you can pretty much go ahead and create your console application, maybe any sort of application to consume, .NET application to consume a Apache Spark app. Like I've mentioned, you can use Apache Spark with C# or F#, and this is the whole of this whole suite is designed for high performance and performs well on TPC-H benchmark, and it gives you this is the stat which gives you the idea that how much time it is basically it takes to run an application which is often and which is basically in Python. So the TPC-H benchmark consists of a suite of business-oriented ad hoc queries and concurrent data modifications. The queries and the data populating the database have been chosen to have broad industry-wide. So total execution time for a couple of queries in TPC-H benchmark, which is the lower the better, here is, so data source from an the data here shows from an internal run of TPC-H benchmark, and it uses a warm execution of Ubuntu 16.04, and I'll probably show you a link where where you would like to read more about .NET Apache Spark performance. So there is this blog which is written which is written by which is basically a .NET blog, and it gives you the whole a lot of details when it comes to how to create your Apache Spark application, how you can measure the performance, what is the TPC-H benchmark, and what's next for it. It gives you the full roadmap, and you can anyways have the GitHub repository, explore the GitHub repository for that matters. Other benefit of Apache Spark is it lets you reuse all the knowledge and skills, the code, the libraries you already have as a .NET developer. So your data processing code can also be utilized. The large ecosystem of libraries to .NET developers, such as something like Newtonsoft JSON, ML.NET, MathNet.Numerics, or maybe Node.time, and much more. And apart from it, you can build anywhere and run it anywhere. So can be used on Linux, Mac, and Windows, just like the rest of the .NET, and it is open source and free. So .NET for Apache Spark is available by default in Azure HD Insights and can be installed in Azure Databricks, Kubernetes services, AWS Databricks, AWS EMR, and much more. Okay, so Now we know what is ML.NET and how it is basically helping you. Let's just move towards the another branch of the Microsoft's AI ML offering, which is Microsoft Azure Cognitive Services. So what is cognitive services? So cognitive services are the cognitive capabilities provided by Microsoft Azure. So they take care of the hard part of the presentation of the data, training that data and implementing an algorithm on on that, and on top of it, it is exposed via a REST-based API, right? So what we basically use machine learning to make our application more intelligent because it enables us to detect pattern. And to do this, we need a lot of representative amount of data, and we need an ML algorithm that trains a model to detect patterns, and these things are difficult to create. But leveraging Azure Cognitive Services, this process is going to be very easy. Cognitive services are RESTful APIs and that expose a machine learning model to the outside world to do amazing things. This enables your application to just consume the goodness of machine learning as a service. And for most of the service, you can do you don't have to gather the data, create an algorithm, and train the model. So if I have to show you the process of how you do it, it's as simple as that. You have the data, you have the patterns available, and in this data we already have the pattern. We just need to find patterns and create and test the algorithm. That can be a deep learning algorithm and clustering, and you have the model which is supporting to you, and then you can expose that particular model to the application. And that's how you don't need not to do all these activities here. You already have the REST based API, and that model is that API is basically already exposed. It has different capabilities. There are services that detect things in the image, and that comes the catalog portion of the cognitive services. We have vision, we have speech, we have language, we have decision, we have web search. You already know about face detection. We already know about text to speech, speech to text. We already know about Q&A maker, text analytics, anomaly detector, personalizer, and if you have ever worked on Bing, you already know spell check, image search, entity search, custom search. All these which are in red here were in preview when this diagram was created. I have created this thing a couple of weeks back. So yeah, that's there. And this is the whole whole idea of what cognitive services offerings are in terms of leveraging the artificial intelligence landscape in your application. Let me give you a quick demo of Azure Cognitive Services. I'll simply going to log into my Azure portal, and once I'm logged in, I can go to any resource which I would like to create. You can just go ahead and do cognitive here, and once you are here, cognitive services, I do not have any cognitive services as of now, so I'm gonna go ahead and do add. You can just go to if you know what you would like to create, if you know that you would like to make a Q&A maker or a face API or a speech API, you can just simply go ahead and type that here. I just wanted to show you how easy this is. So that's there. I'm gonna do click on face, and I'll do create, and you just need to select the create a resource group. You just need to have the region, my test face API, and you need to select the pricing tier. For this demo purpose, I'm selecting free. You also have standard, which is like 10 calls per second, and you will end up paying it for the resources which you are consuming. You just go ahead and do review and create, and once the validation is passed, you would be able to create. And that's how it is. I mean, that's easy it is to make the to create the APIs, to create the resources in Azure portal, and you would be able to consume it in a in a matter of seconds. So that's there. Let's just also touch base the third branch of Microsoft's AI ML offering, which is Azure ML. So what is Azure ML? Azure ML is basically an enterprise grade machine learning service which is used to build and deploy the models faster, the models which we have created, which we have created and consumed in the previous in the previous couple of slides back. So it empowers developers and data scientists with a wide range of productive experiences for building, training, and deploying machine learning models faster. So you have an accelerated end-to-end machine learning life cycle. You can leverage MLOps, which is a DevOps practice for machine learning. You can innovate on a secure and a trusted platform which is designed for responsible ML. You get ML for all skills. You have end-to-end MLOps. This is basically, you also have the flexibility of leveraging responsible ML. So responsible ML capabilities are something like where your models are capable enough to understand with interpretability and fairness, to protect the data with differential privacy and confidential computing, and to control that data, to control that ML lifecycle and audit trails within that particular data sheets. And it is open and interoperable. Having said that, this is what I was talking about. You have ML for all skills. You have productivity for all skill level. You can code with built-in collaborative notebooks and one-click Jupyter experience. You also have drag and drop designer, and I have recently shown you a demo of automated machine learning for accelerated model development. You also have the robust MLOps capabilities that integrate within the existing DevOps processes and help manage the complete life cycle. You have the best-in-class support for open source framework and languages including MLflow, Kubeflow, PyTorch, TensorFlow, Python, and R. And on top of that, you also get responsible ML capabilities, where your application would be able to understand models with interpretability and fairness. You can your application the data will be protected with differential privacy and confidential computing, so on and so forth. So then what are the Azure ML capabilities? These are some couple of key service capabilities. You have collaborative notebooks, a one-click Jupyter experience. You have data labeling, where you can prepare the data quickly and manage and monitor the labeling projects, and automate iterative tasks with machine learning assisted labeling. You also have auto scaling compute, where you use managed compute to distribute training and rapidly test and validate and deployment of your models. So you can create CPU cluster, you can create GPU cluster, and these clusters can be shared across a workspace to automatically scale to meet your ML needs. You have you have enterprise grade security, where you can build in and deploy models securely with capabilities like network isolation, private link, role based access control, all of the features which you have in Azure for security, maybe managed identity for compute resources, something like that. And and the most important part of it is that you you would be able to better manage resource allocation for Azure machine learning, and you can leverage the compute with workspace and the resource level quota limit. So you would be able to manage, or I would say you would have more control over the cost, and that's where the cost management part comes into the picture. So I'm quickly gonna I'll show you how to create how to leverage the machine learning Azure machine learning platform over Azure portal. So the first thing which you need to do is you need to have a workspace in your Azure portal. So you just need to go to to your home page and select click on create a resource and select machine learning. This is something which I've already done. You just need to select your resource group. I need to create my I need to give the workspace name. So I'm gonna give AZML, something like NSAZML workspace, and you can select the location of your choice. I am going to do review and create because I do not want to go ahead and do all these activities. But what I should do is check the networking tab. What sort of the default configuration here is public endpoint, which is accessible to public internet. But if you would like to limit your workspace to an Azure virtual network, you can go ahead and create on private endpoint as the connectivity method, and then once you will be clicking it, you would be able to add your private endpoint. You would be able to create your private network to configure that endpoint. I'm going to do review and create, and that's how that's how you create your machine learning workspace. Once you are done with that, you can pretty much go ahead and leverage this workspace to maybe create a model with automated ML in machine learning. So you just need to sign into your Azure portal once this deployment is done, and then you need to sign into Machine Learning Studio, which is your ML.NET Studio. I am going to my resource. I'll go to dashboard, I'll go to resource group, and I'll select this. My deployment is in progress as of now, so it is going to take a couple of minutes. But what you need to do is, once you have created your workspace, you can go ahead and select that workspace from here, and that's where you would like to, if you would like to use notebooks, if you'd like to use designers, if you'd like to use automated ML, you can simply just go ahead and whatever assets you have, maybe experiments, pipeline, models, data sets, endpoints, that will also be accessible to you. So it is going to take a couple of minutes, and there are a couple of activities which you would be doing. You just need to select the workspace. Once you have created the workspace, then you need to in the left pane you would see something like automated ML. Click on that, and then you need to just load the data set, or maybe create the data set. And there is a very good help available in the in the MSDN, in the Microsoft documentation, in the Azure machine learning documentations, where you could just go ahead and try using that, and you would be able to do a full-fledged automated ML experiment by in a matter of seconds. So let's just go to the workspace and see if that is created or not. I'll just refresh the workspace. I'll just walk you through with a couple of workspaces. So that's my default directory. That's my pay as you go, and this is the workspace which I have created, and I'll just go and do get started. Once I've clicked on get started, I was telling you about automated ML, and you just go ahead and do new automated ML. And once you have done that, what you would like to do is create the data set, load the data set, and then you need to configure it, and you would be able to execute that particular data set. So to create that data set, you will have a couple of options here. I have already downloaded the form, so I would like to select by a sample data set. So I would like to have select from local file. You just need to give the name of the data set, the version of the data set, and then what is the form of the data set. The data which I have downloaded is somewhere on my machine, which I am going to show. Automated ML. So this is the data which I have downloaded here, which is a CSV format of the data, which is benchmarking. It has age, job, marital status, education, default, housing, loan. It is basically a bank marketing data which I would like to train with the help of automated ML in the end. So that's there. So what I need to do is I just need to give the name of the data set, my data set, and what is the form of the the type of the data set, in which form it is. It is a tabular data set, and we click on next. So we would like to here in this section, we are simply selecting the default data store which was automatically set up, and I would like to select my own data set. So this is the Azure blob storage. I'll just go ahead and browse it, and then I'll go ahead here and go to the folder in which I have created, and then click on open, and my CSV is open. Right, once I'm done with that, this is the file you downloaded as a I have downloaded as a prerequisite because I wanted to work on this specific file. Then I am simply gonna do to go next, and that's where my upload is done, and it is basically verifying the the data. So this is the delimited file format. It is a comma separator file. This is the column headers. So if I'll just if you would like to tweak it, you can just go ahead and tweak it, and or maybe you can just say, so ID, age, job is basically, these are the headers. Do I like to skip row? I don't like to skip any rows here, so you can just go ahead and you can just see the data, what is being displayed here, and you need to click on next, and that's where you can just see this is schema form. Basically allows for further configuration of your data for this experiment. You can toggle it to whether you would like to you would want to have that information in your schema or not. Maybe something like month, or maybe a day of week, and let's just skip month for now, and let's say next. And this is the basic section, basic confirmation screen, where I will be using my automated ML, and once I go ahead and click on create, you would be able to configure it. So this is the data set selection, and my data set is there. I have selected it, and I'll go ahead and I'll do next. So I have already my data set was already selected, and I just need to create a new experiment. So I'll call it my first automated ML experiment. Once you are done, you want your you would like to select your target column. These are the columns which are already there. I'm going to select Y. Now I do not have any compute cluster in my machine, so I would like to go ahead and create a new compute cluster, and this is going to take a lot of time. So you just need to be sure of because this is where you're going to charge. So you just have to select what sort of compute you would like to have, and then once you are done, once you are done, you do next, and then your task type and setting form, you just need to complete the basic setup, specify the task type, you get the classification and related stuff, and then once you are done with that, once you have this whole exercise done, you would be able to explore your models here on the models tab. On this tab, you would be able to explore your models here, and you can pretty much go ahead and deploy the best model. And once you are done, please do not forget to clean up the resources by deleting the resource group. So thank you so much, guys, for having the patience to listen to me. And if you have any questions, please feel free to ask me. Please feel free to reach out to me. Thank you so much, Ilyas and the team, to giving me the opportunity to speak here at AzConf, and I'm so grateful for that. So thank you so much. Thanks a lot.